All right, this is the worksheet we were doing in the notes today during the Zoom call. Make sure you have your periodic table handy when you are doing this worksheet. What we are going to be doing is we're going to be looking at this periodic table from now on, but we're going to be using the bottom part here. Okay, so if I ask you to look for aluminum or phosphorus and you don't know where those are, please try to get familiar with this periodic table. Okay. So if you look at this bottom ones here, if you remember this, I had you guys put charges on your periodic table, and I told you to put +1 on top of this, +2 on top of this, +3 here, ±4, -3, -2, -1, and 0. The purpose was that all of the elements that are in group 1 right here, they are going to have +1 charge. All of these are going to have +2. So now let's scroll down here and look at these the bottom of this paper. Okay, let's look at the bottom of this paper right here. Look, all group 1, they're all +1 charges, +1, +2, and in fact this is the periodic table of ions, and that's what we're going to use from now on. Okay, this is +3 right here. This is ±4, -3, -2, -1. All right, and look, I didn't give you noble gases in the ions because they are very stable. They don't lose or gain electrons. So when it's a positive charge, you're losing electrons. When it's a negative charge, you're gaining electrons. So remember the stuff that we learned in Unit 1. We cannot forget that. You have to make sure that you remember that. Now let's go to that worksheet, and we are going to be using this stuff right here. Okay, these charges. Okay, so the top part you can get from the notes, that's not a problem. So let's do the this stuff right here. It says calcium, show original electron configuration. So let's go back to that periodic table and see what our calcium's configuration is. Calcium is in period 4. Okay, and it's in s orbital, so this is 4s2. Now on the top of this periodic table you have your general configuration order right here. So you know calcium is 4s2, write down 4s2 and then copy everything else you see here. Copy everything else you see here, which is 3s2, 2p6, 2s2, and 1s2. So let's go back to this. We are going to go ahead and put down everything. 4s2, that's calcium's configuration, and then we're going to do 3p6, 3s2, 2p6, 2s2, and oops, I already got 2s2, and then you're going to put 1s2. All right, remember these little numbers up here, superscripts, these are number of electrons. Now when calcium, you look at the calcium in this periodic table, you notice that it has a +2 charge, which means it loses 2 electrons. Positive means it loses electrons. All the metals lose electron. Okay, metals lose electrons. Positive means that you have lost 2. +2 means you've lost 2 electrons. Remember your basic stuff from Unit 1, cannot forget that. So you're going to come here and do -2 because calcium gets a +2 charge. -2 electrons means it loses 2. We are going to get rid of this right here because this is 2 electrons. Okay, so your answer is going to be 1s2, 2s2, 2p6, 3s2, 3p6. So now this is the new configuration of calcium. Okay, notice we lost that orbital 4s2. Okay, when it loses 2 electrons, its electron configuration changes. So now we need to go back and see who has this configuration, because if you count these electrons, we've got 6 + 6, 12, 14, 16, 18. So we need to go back and see that whose configuration in the periodic table is 18. Who has 18 electrons? And for that, notice this is only for the ions, guys. This periodic table is for the ions. We need to scroll up and see who has 18, and that is argon. Argon has 18 electrons, okay? Argon has 18 electrons. So calcium, when it loses 2 electrons, it becomes like argon. And that's how we're doing this. Let's do the next one, aluminum. Aluminum, let's go ahead and go back to the periodic table. Notice where aluminum is, right here. This is the P zone. Remember we did that? This is all gonna be P, okay? And your top, this periodic table right here, and also tells you that this is the P, okay? So aluminum is going to have 13 electrons, which we need to represent in that electron configuration. Okay, so which means that aluminum is in the P zone. All right, aluminum's configuration is 3p1. It's in period 3 and its configuration is 3p1. So look at our general order, 3p1. We're going to put everything else before that, which is 3s2, 2p6, 2s2, and 1s2. Let's go back to this. So we are going to put, let me change my pen again. We're going to put 3p1. All right, 3s2, 2p6, 2s2, and 1s2. Now look at your ions periodic table and see the charge on aluminum. Let's scroll down. Aluminum has a charge of +3, which means aluminum loses 3 electrons. And I also gave these charges up here, okay? Just a reminder, I gave you these charges in your periodic table before as well. So when it's a positive charge, remember it loses electron, okay? It loses electron because it's lost the negative charge. It's become positive, okay, due to the protons. So aluminum has a +3 charge. So this means it loses 3 electrons. Let's go back to this. So the 3 electrons are going to come from this. 2 + 1 is 3. So we are going to get rid of, for aluminum, this whole thing. All right, so this is going to be -3 electron. Our new configuration is 1s2, 2s2, and 2p6. If you count these little superscripts, we have 6 + 2, 8 + 2, 10. And that is whose configuration? If you look at the periodic table, 10 electrons neon has. So neon, it's going to be neon. All right. So these elements lose or gain electrons to become stable, like the noble gases. All right. All right. I hope this part was easy and helpful. Okay. Let's come down here. The other thing that we discussed was we talked about the charges and how the formula is formed and balancing. Okay, why do these formulas happen is because of the attraction and the stability to become like the noble gases. So now when you are doing this part right here, okay, we're going to be looking at the charges again. Look, it says sodium and sulfur. 2 sodiums are needed to cancel the -2 charge on 1 sulfur. Once again, we have to have our periodic table of ions in front of us. Sodium has a charge of +1. Sulfur is -2. All right. So let me show you how we're making that balance. I'm going to do this here. Sodium, just so that you can see it, okay? Sodium is +1, sulfur is -2. Remember, I told you what you're going to do is you are going to swap and drop the sign. Sodium is going to get the 2 from the sulfur, and sulfur is going to get that 1, okay? But you don't need to put 1 because I see 1 sulfur, there is a sulfur. Okay, so how many sodium do we have in this formula? This subscript tells me there are 2 sodium. Each of the sodium has a charge of +1. How many sulfurs we have? We have 1 sulfur. In this formula, we have 1 sulfur. Each of the sulfur has -2 charge, so 1 sulfur. Let's do the math here. This is +2. This is -2. +2 minus 2 is 0, which is why when you put together this formula here, there is no charge on it because the charge has been balanced by each of their charges. Okay, so 2 sodium are needed. That's how many we have in this formula, 2, to cancel the -2 charge on sulfur. All right, that's why you need 2 sodium to cancel the -2 charge on sulfur. Let's go ahead and do, all right, you can pause this video, rewind, whatever, to watch this again. I want to go ahead and do one more. Let's look at the aluminum. Okay, so the charge on aluminum, let me go back to the periodic table again. Charge on aluminum is +3. All right, and the charge on sulfur is -2. So let's go back to our worksheet here. Aluminum has +3. Okay, I'll put it here. Sulfur -2. So let's do that. Aluminum +3, sulfur is -2. We're gonna bring this 2 at the bottom. Why am I doing this? Because it's the easiest way to put together the formula. Okay. All right, so you will, a neutral formula without any charges. So you will have aluminum is going to get that 2 from the sulfur without the sign. We're not going to put negative. We're not going to do this. Al -2 and S +3. No, this is wrong. Aluminum is going to get that 2. Sulfur is going to get the 3. This is what we're looking for. So we have 2 aluminums are needed to cancel the +3 charge, to cancel the -2 charge on how many sulfurs? 3 sulfurs. Okay, -2 charge on 3 sulfur. Okay, so let me show you this, how this is happening. Aluminum has +3, aluminum, and sulfur has -2. If I bring in one more aluminum, I have total of +6. If I bring in one more sulfur, it's -4. Which means I need to bring in one more sulfur so that this is -6 and this is +6. +6 minus 6 is 0. Okay, I hope this was helpful, and all you're putting here is just the all you're putting here is just these subscripts right here. So it's going to be Al2 and S3, just this formula. Okay, and that's your ratio. So check to see if you can get K2O for this, Ca3N2 for this, for the ratio, which is the formula. Okay, and then NH3 for this. This should be Na3P, and this should be MgO. All right, I hope this was helpful. I'll see you again tomorrow, guys. All right.